developers, they brought in a pre-built application with Duck Hunt, and they use their it is, but they hacked it so it works with the depth perception camera. But they use their arm as a gun, but they didn't even fire it with hand gestures. They hit the space bar. So yeah, it was supposed to be like the most creative or whatever. So judging this. Yeah, me. Yeah, but apparently they couldn't get the nodes to work. Yeah.
All right. So how was the homework? What homework? Easy? What homework? Working on it? Okay. Okay, so for those of you who have not gotten started on the homework or is somehow getting stuck, one important part is in C and C++, the type is associated with the declaration of the variable. In assembly language programming, the type is associated somewhere else, okay, with something else. Okay, I cannot explain the whole thing, but it's not when you declare the label when the type becomes important. It is a little bit later on. Okay, there are only a few instructions where the type or whether it's signed or not makes a difference. So you kind of have to make sure that when you get to those points, you say, okay, now I have a choice to look at this from a signed perspective versus an unsigned perspective. But there were only a few places, but they're not the same place where you would expect that from a C and C++ program. Okay. Are there any questions about this part? I mean, this little statement? Yep.
Yeah, I'm kind of concerned about how your script is going to work with our labels.
Okay.
Our labels have to be the same names as the variables?
Okay, yes, you do have to have the same names, the labels, L1, L2, and then the quote-unquote variables, they all must have the same name. Because what I'm doing is I will stop at certain labels, I will inject values into your variables, and then I will let your program continue to run. So I will basically I have test cases for your program.
But it's going to be based off the names of our variables, right?
That is correct.
Okay.
Can you give us an example of the layout of the required labels?
Absolutely. Let's go to the homework assignment, and then we'll take a quick look at that. All right, so here is the homework assignment, and I'll go, okay, create a folder for today. All right, so all right, so this is the pseudocode that I give you. Some of you can actually, if you want to, you can kind of add the appropriate pound include, the main, and so on and so forth to turn this into an actual C program and see how it works. Okay, because that's one thing that can be helpful. Is if you don't know how the high-level code is supposed to work, it's really hard to debug the assembly version of the same program. So one thing you might want to do if you really want to is to trace this code in C, so that you know exactly how it works, and then you can do the conversion to assembly language. I think that makes sense. The important part is the names of the variables: dividend, divisor, quotient, and remainder. Those are all important. Okay, so you need to keep the same names as these four names, because I will inject and check the values of these specific variables in my script. Is that okay? Okay. The next thing has to do with the location of label L1. So label L1 has to be at a place where it is before you put any one of these variables into registers. Okay. In other words, I will put a breakpoint at L1, and my script will inject specific values into dividend and divisor as to test your code. Okay, does everybody understand what I mean by that? kind of? Okay. The location of L2 is also very important because I will also stop at L2. And when I stop at L2, I will check remainder as well as quotient to see whether the result of the algorithm is correct. So L1 is for setting up the test case. L2 is for checking whether your algorithm is doing the calculations correctly. Are there any questions about this code? Did I answer your question? Okay, all right, very good. Any other questions about this code? Yep.
Can we initialize the variables when we declare the labels, or?
Yeah, you can. I mean, you can initialize it up here
So
when
we
you
won't
specify
need
the dot
those,
int.
We won't need those 3 lines of code.
That is correct. You do not actually need these 3 lines of code. It's just one extra place where you can put different values into the variables for testing purposes. One of these you do have to initialize. The quotient has to be initialized before the loop. So this one has to be initialized, like right there. All right. Any other questions? No other questions? All right. It's due in 2 days on Thursday. So if you have not started yet, today is a good day to get started on this one. All right. So getting back to our notes. We are almost done with operating system calls. Okay, how do you request a service from the operating system? So what I'll do next is I will go ahead and do a homework assignment for myself. So this is a homework assignment for myself, and I just want to do something like this. So we'll go through the C code first, and then we'll go through the conversion into assembly language, just so that we know how this works, okay? It is not really exactly the same as your homework assignment, but as I work on this program, you may find the process itself useful, and you can transfer some of the tricks of the process to doing your homework assignment, right? So in this case, I'm doing, this program does base conversion. Specifically, it is converting to base 2, okay? So well, I shouldn't say converting. It's going to print values in one of the variables in base 2. So we'll go ahead and take a look at the program first. We have unsigned dividend. Since I did not use uint32, it's assumed to be 32-bit. We have dividend, remainder, divisor, and quotient, just kind of like your own program. And then we have an extra variable called count. Count is basically just controlling how many times we have to go through this loop. This is a very typical, it's a very typical way to create a loop that has to go through a certain number of times. Does anyone want to tell me what this does? When does this loop exit? Yep.
When count equals 0?
When count equals to 0, it gets out of the loop. Okay, that's right. In other words, there's an implicit comparison of count to non-zero. Okay, so as long as count is non-zero, we stay in the loop. The left shift operation, for 1 bit from dividend into the remainder, left shift quotient 1 bit. Left shifting is easy to do. We already know how to do left shift. Right shift is a little bit harder because it involves division, but left shift is easier. How do we do left shift when these numbers are all unsigned?
Multiply.
Well, we can do multiply by 2, or we can do
SHL. Shift left.
Shift left, but we don't even need that. With only the instructions that we have talked about so far, we can do a left shift already. Which instruction do you think will do the left shift? No, the add instruction. Because you can add something to itself, and therefore doubling, which is multiplying by 2, and that's the same as a left shift operation. Okay, so we can do this part already. We have a comparison if the remainder is greater than or equal to the divisor. This is just subtracting the divisor from it. Increment the quotient and print basically just a single 1 to the screen. Otherwise, we print a single 0, and then we decrement count by 1, and then we just keep on doing this until count gets down to 0. So this code here is really just a simple program to print a number. In this case, it is. Yep, go ahead.
What's with the parameters of your right function?
The right function?
Yeah.
Okay, the right function is basically equivalent to system surface number 4. Okay, because we are basically printing, or we are sending out a byte to standard out in this case. And there's a direct correspondence between a write call to system surface number 4. System surface number 4 means EAX has to have a value of 4. This is what EBX should have, which is the file handle. File handle 1 is standard out. This is what should be in ECX, which is the location where you're printing from. And this one is EDX, which is the number of bytes that you're printing to the file handle. So there's a one-to-one correspondence between the parameters to registers that you have to initialize before a int $0x80. Okay, so we'll keep this one in on screen as we work on the actual code. Or the other way to do it is to copy and paste it, and then we'll do some commenting in the program, and we'll do it that way. All right. So we'll go ahead and create a new program, and I'll just say print in binary, and this is going to be the assembly version of the program. Paste. Control D to stop the capture. The indentation is all gone, so I'll go ahead and fix the indentation first. All right, so this is the file, and we'll go ahead and fix the indentation. Set shift width to 2. This is something that's really cool about VI, is it knows where to find the closed curly brace, so I can do indentation fairly easily. So. Uh-oh.
Didn't find that one.
Didn't find that one. How did they get confused? Oh, okay, I think I know. There we go. I was using the wrong key sequence. There we go. So we got all the indentations correct. And then the next thing I will do is to put a pound sign on the left-hand side, so all of these lines become comments, and then I can disperse my assembly code in between. And in VI, that's pretty easy to do. From line 1 to the end of the entire program, substitute the beginning of each line with a pound sign followed by a space, and voila.
Easy peasy.
It's all being recorded, so you can go back and watch the whole thing. Yeah, it is regular expression. Regular expression or regex, is actually a very important thing. It's going to be very useful in your computer science, career when you get out to the field. Okay. How many people know how to work with regular expressions? Okay, kind of. Well, just getting into it is important. Okay, just understanding is important. Is really, is a first step. It's very useful in text processing. It's also very useful in database, stuff. It's also useful when you're just working with an editor that has the ability to deal with regular expression. So we'll go ahead and start with this program. So the first thing is, we have to declare all the so-called variables in the .data section, because we're going to change some of these. Okay, so we'll just go ahead and say dividend :.end. If I don't know what it's supposed to be, I can just put a 0 here. I don't think I used all of these particular variables, because I think at some point I changed the program. So I'm just going to. I'll do exactly the same thing, that is specified, but not every single one is actually used.
Dot in.
Yeah. And then we have count here. That's the only one that has a specific value. Then we have to switch back to .text for the actual code of the program. Remember to export .global_. underscore start, underscore start starts here. Okay. And which number do you think I'm printing out in binary in this case? Okay, let's take a look at the variables that are actually in use in this case. We have count, we have remainder, we have divisor, and that's it. Well, we got quotient. So which one do you think is actually being used? Oh, we actually have dividend too. So which one is the number that is being printed in this case? You can convert this code into C and actually run it as a C program. All right, let's take a look at the direction. Okay, what is the source of all this, all these operations? We are shifting 1 bit from dividend into remainder. So which one do you think is the source? The dividend. Okay, so we are actually printing the dividend in base 2 in this program. All right. So let's go ahead and start with the first line here. How do we convert this into assembly language?
So if statement.
We convert it into if statement. Very good. So we can convert it into if not count, go to loop exit, and then the loop exit is going to be over here. Now loop exit doesn't need to be or commented out because it's the same in assembly as well as in C. So this one I'll just do it in assembly. Okay, so now I have if not count go to loop exit. How do I do this in assembly? Well, first of all, what is the actual meaning of if not count go to loop exit? Isn't that the same thing as when count equals to 0, go to loop exit in C? Right? Okay, so now we have a comparison. Now before we don't have a comparison, it's an implicit comparison. When we have this code in this format, it's really confusing because we are doing a negation on an integer, which doesn't seem to make a lot of sense. But in C, it does make sense because it really translates to is count 0. If count is 0, then not count is true, and then we're going to exit the loop. All right. And how can we do something like this? Well, first of all, are we ready to convert this line, the line that is above the green cursor? Are we ready to convert it into assembly code? Or do we have any extra step that we have to perform? It's a single comparison followed by a jump, right? So we should be able to do this using one compare instruction followed by a conditional branch instruction. Okay, so let's go ahead and write the template of the instructions first. CMPL, because we have 32-bit integers, we're comparing something to something, and then we do a conditional branch to a particular label. We know what that label is. It is loop exit, so we can just fill that in. So the question now is, how do I fill in these 3 question marks? Okay, do you remember how to read this? Branch to loop exit if and only if this value relates to this value using this particular way. Okay.
$0, count.
Yep. So JZ here for the result being 0. And what am I comparing to count?
$0.
$0 for immediate operand, and count is just count because it is a direct operand in this case. Okay, so we have our first conversion into assembly code. Okay. So do you think I can test this code at this point? Well, I can kind of test it, okay? Because what I can do is instead of initializing count to 32, I can initialize it to 0 and make sure that it bypasses the entire the whole thing, and then go to loop exit as a label. But let's go ahead and finish the entire loop construct first, because at the end of the loop, we also have to remember to jump all the way back to the beginning. So in this case, let's label that as loop begin. And loop begin has to be before the while, so we put loop begin here. And then there's one more thing that I can easily implement. Can we implement count minus equal 1, which is also minus minus count? Can that be implemented using a single instruction in assembly language? Okay, how do we do that? We have two options actually, because we can subtract 1 from count like that, but we can also, if you want to, we can also do an add L, -1 to count. Both of these are acceptable. Okay, they do exactly the same thing. Neither one is faster than the other one, so it doesn't really matter. I'll just use this one because it seems to make more sense. Okay, well, maybe I should test this program already. But Tack, you're not quite done yet. There's a large chunk of the program that I have not done yet. But I want to test it, even as it is. I just want to make sure that it goes through the loop exactly 32 times and then exit correctly. Does it make sense that I want to test the program kind of in a much more incremental way than you normally are used to in your C and C++ program? Because assembly language programming is a lot more tedious, which means you can make tiny little mistakes and cause your program not to work. So that's why you want to take baby steps, write 5 lines of code, test it. If it works, then you can continue. If not, you know where the problem is. It has to be the last 5 lines that you changed or added. Okay? If you use get, git get, I would do a commit right now, just to make sure that I know this particular snapshot of the program, test it, and then see if I need to make any changes to the program. How many people have started to use get as a revision control software program? Not yet? It's good to at least think about doing it, because as the programs get more and more complicated, the value of revision control will become, will continue to increase. Yep.
You just sign up for a free account through.
You don't need to sign up for anything. Get can work locally. Yeah. You just go to Get tutorial online, and they will show you exactly what command you have to do, just to do it locally. Completely, just do it with this folder. Yeah.
Does it work with like C or C++?
Absolutely. It works with any text file, so it works on HTML and XML files too. Yeah. So anytime you have a text file as a source file, Get works exceptionally well with that. It also works with a binary file, but it's not nearly as efficient because it's really hard to diff 2 binary files and then say, oh, you need to tweak these files to make these 2 files the same again. But with text files, it makes a lot of sense. All right. So this program is almost done. I'll just go ahead and put a no op here. I'm not even bothering to finish the entire program. So we have g stabs -o bin.o bin.s. So, and I would use GDB to debug the program. All right, so and when I debug the program, I can actually debug the entire program. So I'll put a big breakpoint at loop begin, and then just go ahead and run the program. So we have a compare JZ. It should not branch to loop exit because count has a value of 32 to begin with. So we'll go ahead and single step, and sure enough, it's not going to loop exit. It's subtracting 1 from count. So it should keep doing this for like 32 iterations. And if you want to, you can print count to look at this value. Because in this case, count so happens to be a 32-bit integer, and print assumes the variables are 32-bit too. So that's why it just kind of works out in this case. Okay, so you can basically just keep running the program, but I'm not going to keep doing this. I'll put a breakpoint at loop exit, and just use C to continue the execution of the program. And first of all, this is good because, oh, okay, it's continue. There we go. Oh, one too many times. When it got to line 40, I should have printed count to make sure it's 0, but I kind of missed that chance and typed C just one more time. One time too many. But anyway, this seems to be working. So I know the control structure itself for the loop itself is working. So now I feel confident that I can move into the loop and continue to work on the logic of the program. Is that making sense so far? Okay.
Even after that segment fault, can't it, you still print C?
I think so. Unless whatever code it executed before it gets into the segmentation fault, change the variable. So count is 0. Yeah. So, yep. All right. So the program is working up to this point, and we can go ahead and use revision control to take a snapshot. Now, since I'm talking about it, I should probably just look it up and figure out how to use get to do this. That's not what it is showing here. Get init add and commit. Okay, so get init get. I think the next one is add. Okay. In this case, I don't need to add the entire folder. I will just go ahead and add. Sorry.
Oh. Okay, never mind.
I can add just one single file, and then I can commit. Now, when you commit, it wants me to
Git add dash or git add space dot. You might take care of that one.
I don't know. You mean get add dot?
Yeah.
I don't think so. It's not a. The commit issue has to do with I did not specify who I am. So we'll go ahead and say get. You just need something. Okay, still complaining. Here we go. Little things. So we'll go ahead and enter the commit message. Okay, the loop construct is working. But this is the initial commit, which means I just need to describe the files.
So you can do a commit -am and do that message in line.
Oh, okay.
You gotta do it within quotes, so you gotta wrap it in quotes.
Got it. So we'll just say print bin.s is a source file. All right.
It gets cooler.
Oh, this is actually committing all the files because we had that get add dot. Yep. All right. So we do have one snapshot at this point, which is good. This gives us a baseline to go back to. So now I can go back and continue with this program. Print bin.s. All right. So let's deal with the shifting part. Okay, we want to shift one bit from dividend into remainder, and left shift quotient one bit. Okay. All right, so let's deal with the first one first. How do we left shift one bit from dividend into the remainder? Now, what this is implying is the bit that is shifted out of dividend is shifted into remainder as the least significant bit. Okay, because they're both left shifting, so that means when you're shifting into remainder, you're shifting into the least significant bit. Yep.
Isn't it add with carry?
Exactly. All right, very good. So the first thing we have to do is to put dividend into a register first. So we'll go ahead and say move L, dividend into a register. I'll just pick EAX in this case. Add long EAX to EAX because that's basically the same thing as a left shift operation. And after this, I want to store the result back into dividend, like that. But now the carry flag is the bit that is shifted out of the dividend, right?
Isn't it ADC?
Sorry?
Isn't it ADCL or out of carry?
No, this is just add because I'm shifting. I don't want to shift anything into dividend, but the bit that is shifted out of dividend, I want to shift it into remainder. So the next instruction is add with carry into, well, not yet, because I have to make room in remainder as well.
Oh wait, if you're putting dividend into EAX, and then you're adding EAX to EAX, isn't that the shift right there?
Right.
So
The
what-
remainder has to be shifted too. Because remainder needs to be left shifted as well, so I'm gonna copy the same code here. Oops. There we go. So once again, using the command part of VI, you can do these things. It's pretty handy. And now we can do one add with carry long to 0 to remainder. Okay. Okay, if I want to draw a picture of this, okay, this is the easiest way to do it. Okay, this is our dividend, and this is our remainder. Okay. If I want to shift everything to the left, just one, what is shifting into dividend? I don't really care. So for the most part, I just want to put a 0, shift a 0 into the least significant bit of dividend. Okay, that's fine. Remainder is going to be left shifted to, so whatever is shifted out of remainder, I don't care either, because that bit is going to be lost. What I do care is this bit here should be shifted here. So that's why when I added EAX to EAX, when EAX is dividend, this carry bit is important because I want this carry bit to be the least significant bit of remainder. And that's what that add with carry long is useful for. Am I still doing okay so far? Do you think I can test this program right now? We should be able to do it, because if I put anything into dividend and it's just shifting 32 times into remainder, whatever was in dividend should now be in remainder, right? So we can test the program just the way it is. But I do need to make sure that dividend starts with some particular value. So we'll just give it A, B, C, D, 1, 2, 3, 4. Okay, just a particular bit pattern. Okay. So we'll assemble, link, and then GDB the program again. And depending on, do you think this program is going to work? No. We'll see how it works one iteration at a time, okay? Because some people are not convinced that it's going to work. So let's go ahead and put a breakpoint on line 23. Okay, so now we are stopping on line 23. This shouldn't do anything because remainder was 0 to begin with, and left shifting 0 will still give us 0. So that part is fine. We want to do print dividend, and we want to print it as a hexadecimal value so that we can see A, B, C, D, 1, 2, 3, 4. And then we continue with the 3 operation here, the 3 additional instructions. If I print dividend at this point, it should be shifted already. So what is A, B, C, D, 1, 2, 3, 4 left shifted by 1? How do you do it right here? Okay, so we have A, B, C, D, 1, 2, 3, 4, all in hexadecimal digits. A is 1010, B is 1011, C is 1100, D is 1101, 1 is 0001, 0010 is 2, 0011 is 3, 0100 is 4. And we should have a value that is left shifted by 1, which means we are moving the bits this way. We're padding a 0 here, and this becomes the new number. Now, if that is the new number, the least significant digit in hexadecimal, this is what? This is 8, and 8 is just 8 in hexadecimal. And then this one is 6. And then we got a 4, 2, that's an A. And just want to make sure that I'm still aligning everything correctly. That's a 9. And this one is a 7. And then we have a 5 here. So after shifting, we should see 5, 7, 9, 8, 2, 4, 6, 8. Well, let's double check. But this only works if you print dividend in hexadecimal, and it is 5, 7, 9, 8, 2, 4, 6, 8. Okay, wow, that actually works. I'm just surprised that I did not make a stupid mistake somewhere, like not counting the bits correctly and stuff like that. All right, so it does work. What about that bit that is shifted out? Once we single step the last instruction, that should be shifted into the remainder. What bit did we shift into the remainder? This one here, right? So at this point, remainder should have exactly just 1, right? Because it's 31 zeros and with the least significant bit being a 1. So we'll double check that and look at print remainder. It's just 1. So I'm kind of fairly confident that this is working. So I'm going to delete the first breakpoint, and we'll go ahead and put a breakpoint at the very end of this program. Put one at loop exit, and continue the execution of this entire program. And we'll go ahead and print remainder. Whoops. Print it in hexadecimal, and we have the original number back. So the shifting is working just fine. Is that okay? All right, so now that I know a different part of the program is working, I'm going to check in again. So I use get, commit, and with this just one file, I think just okay, I have to specify bin.s here, and then just specify the shifting part is now working. All right, so this is how you use a revision control software. When you're just the only person working on the project, whenever you can, make some changes and verify that the changes are okay, it's doing what it's supposed to, then you can check it in. So next time, if I do something stupid and mess up the existing program, I at least know how to compare it to the current revision and find out, okay, what change did I make to break the existing code? That makes it easier to visualize the changes. Yep.
If you don't have a GUI, if you're using command line Git, how do you know if you have multiple versions of different other versions? So if you have like so many different versions of
Like a tree, a branch. Okay. Do you have the answer? How to do it? How do we do?
use a server called, well, we crush it out. So we have a server called Bones at Git. It's linked to GitHub.
Okay. So let's do a kind of GUI tool. Okay, we have get, archive, branch, list, create, or delete branches. So I think branch will do it.
Oh,
So-
yeah, you get branch, I guess.
So when you look at get branch, it will do the listing. So -- list will do it. Get branch -- list. We don't have any branches.
Oh, you use on that, Jay? Get a link.
Well, I haven't started a branch yet. So you want to display the tree. Let's see if this has a 2.
You do get checkout -b and you can list the branch name. If you want to create a branch off the master, just check out -b.
Yeah, it says right here, note that this will create a new branch, but it will not switch the working branch to it.
That's what the -b does.
Okay, so it will switch automatically, not just create, also
Sure.
switch. All right, cool. But with a regular homework like this, I typically do not need to branch it because I'm not trying 2 different approaches to do something and then have to decide, how only to use one of the branches later on. All right, so getting back to the program itself. But you can see how I'm doing this, really, really incrementally. I'm not rushing and try to finish like the entire code and test it all in one shot. Okay, just write a few instructions. In this case, 7 instructions. Test it and then check it in. Right. This one here needs to left shift the quotient 1 bit. Well, we already know how to do shifting using just the add instruction. So I'm just gonna do this kind of lazy thing and change dividend in this case, dividend to quotient. And quotient should start with I think this one is incorrect. I think this one should be the divisor. Now, since the quotient was 0 to begin with, left shifting it 32 times will still get 0, so there's no way to test it at this point. Because I need the rest of the program to test that part. Okay, let's deal with the conditional statement here. Okay, how do we deal with this conditional statement, the if-else? Well, first of all, we turn it into the ugly portion, the ugly version, which means we check for the reverse of this condition. If remainder is less than divisor, then we want to go to the else label, which I will just call, else. And then the else is going to be here, because else as a label is just marking the beginning of the else part. I also have to add a unconditional branch here to the end of the conditional statement. So this will jump to end if, because otherwise it will fall through and execute the else part. So right here I need the end if label defined here. Okay. Does this one look like it's ready for conversion into assembly code? It has one single comparison followed by a goto. I think it's ready. Yep.
How would you name your labels if you had multiple if statements?
That's a good question, and there's no easy answer to it. Okay. I personally like the nested name, or a name that reflects the nesting of the construct. So if you have a while loop and then a conditional statement in the inside, the conditional statement would have a label that looks like while if something, while if something. So that way it's always unique. Well, it's not going to be always unique. So you need to use a number to kind of number the sequence. So while 1, if 1, and so on. It does get really kind of difficult to track after a while. But we won't deal with algorithms that complicated, so we don't have to deal with really super duper long labels. Okay. So this one is ready. We have to remember compare long, question mark, then do a conditional branch to, in this case, label else. Okay. All right. So ideally speaking, we want to do something like this. We are comparing remainder to divisor. So divisor goes here. Oops. Remainder goes here. And what do we put here? Less than. We should use below, right? If remainder is below divisor, we want to branch. Because these are all unsigned. Okay, you use JL if they are signed, but since these are unsigned, we have to use JB for below. Sorry?
Sorry, I was thinking it was not above, but you just pointed out.
Right, because it's actually just less than. Okay. All right. But this won't work. Okay, let me turn on the line numbers. Line 36 is not going to work because we have 2 memory operands. So we have to move one into a register first before we can do anything else. So we'll just go ahead and move one of them. Move L. We'll move divisor into EAX. So when we perform the comparison, it is going to be just EAX against the remainder. Okay. So this should handle the conditional branch the conditional structure. And then this part here, we cannot do it with one single instruction, because ideally speaking, what we want to do is to say subtract long divisor from remainder. But that's not going to work because we have, once again, we have two memory operands. I have divisor already stored in EAX up here, so I could just reuse that EAX because I have not made any changes to divisor at this point. But not remembering that I have done that already. It doesn't do any harm if I just move divisor into EAX again and then subtract EAX from remainder. So this is not optimal because I already have divisor in EAX, but doing it this way is more reliable because I don't have to rely on, oh, okay, but what if I change that code earlier so I don't put it into EAX? Then I have to change this part. This one means, well, as long as I'm not clobbering EAX that is used by somebody else, this will still work. The next line is quotient plus equal 1. How do we do that? Yep, just add $1 to quotient. Very good. I can see that you guys all understand, what the $ is or what it means when it comes to operands. That's good. Now we have this one instruction here, or this subroutine call that we cannot do because we are not linking with C libraries. So we have to do the systems call here. This one is the same thing as putting a 4 into EAX because it is system surface number 4 for writing. We move a $1 into EBX because that's the file handle for standard out. And then we have the character 1 or the address that has a character 1. We don't have it here yet. So what we'll do is we'll put it here into either .data or .text. This one can go either way. So we'll just go ahead and say the ASCII code of 1, and we'll just say .ASCII 1 like that, and then we have another one for 0. So, oops, 0 obviously needs to be 0. All right, so now that we have that, we'll copy the address of that ASCII into ECX. So in this case, it is 1 into ECX. And then the last one is how many bytes we are printing. We put that into EDX. And nothing will happen unless we remember to do a software interrupt. So that's basically one branch of the instruction. The other branch is a lot easier. Okay. So we'll go ahead and copy and paste line 48 to 52. So 48 to 52. And we want to copy that to 59. Change 1 to 0. Everything else, should be the same. And I think this is all implemented. Are we doing okay so far with this code? Let's go ahead and test it. Segmentation fault, and it's not doing what it's supposed to. I think the pseudocode itself was actually incorrect.
You didn't make the program at the end.
Sorry?
You didn't do the proper exit code at the end.
I didn't do the proper exit code at the end.
Where you told us to put 1 and 0 in EPX.
Right, but it's printing all ones, that is incorrect as well.
Oh.
I'm more concerned about the actual output of the program being incorrect. Yes, you're correct that we have to exit the program using system surface number 1, which is exit. EBX controls the exit code, and then the software interrupt to request the operating system to do the operation. Okay, I think the pseudocode itself is incorrect, so we have to fix the pseudocode first. And I think it is overly complicated in this case. It's overly complicated because all we really need is to know is what bit is shifted out of dividend. If it is shifting a 0 out of it, we print a 0. If it's shifting a 1 out of it, we print a 1. So this, I think this loop is actually implemented. It's a mixture of several algorithms, so that's why it's not working correctly. All right, so time to simplify this code. Do you guys want me to just? Do you want me to just do it the way it's supposed to? Because the program is going to be a lot simpler if I do it that way. Okay, we'll just go with it. We'll just do it that way. I'm just removing a lot of existing code. Remainder is not useful anymore. We just need to print either a 1 or a 0. Okay. All right. So at this point, I have just shifted the most significant bit out of dividend into the carry flag. I'm not even putting it into the remainder. But depending on the carry flag, I can now already determine should I print a 0 or 1. So at this point, I would say J and C. If the carry is not set, I go to else. If it is, set, I continue execution and print a 1 instead. And this should do it already. So assemble, link, print. Okay, well, it did print out a whole bunch of 0s and 1s. Is that correct? In other words, is it printing 1 0 1 0 1 0 1 1 1 1 0 0? Kind of. I can match the first few bits and the rest is a little hard. I think it's printing it correctly. We'll just check the first and the last. The last one is 1 0 0. We're missing 1 0. Huh?
We added the 0 later.
Oh, that's it. That's a shifted one. Okay, that's right. So it does print it correctly. Nice. Okay. Is that okay so far? What if you want to input something and convert it into the internal binary representation? You guys want to do that? Okay, so first of all, let's figure out how to do it by hand first, okay? Because these are all examples to illustrate how to do the control structure, as well as to use system surfaces to input and output. If I enter 5, 8, 6, okay, as the input, how do I convert this into the internal binary representation of 586 as a base 2 number? That's the question. The input is ASCII, right? So 5 is the ASCII code of 5, which is 35 in hexadecimal. 8 is 0x38, and 6 is 0x36. When the program is reading this in, it's going to read this byte first, and then this byte, and then this byte. In other words, it's going to read the 35 byte, and then the 38 byte, and then the 36 byte. So what do we need to do in this case?
Subtract 0x30.
Right? The first thing we want to do is to subtract 30 in hexadecimal, so we get to the value represented by the ASCII code of a digit. Okay? Because otherwise, it's 35 in hexadecimal. Why do I need this 3 here? Now, once we get to 5, what do? We just store it. Okay? Because this 5 is going to be stored, is already in binary when we put it into a register or memory location. So that's fine. When we read the next digit in, what do we do with this 5?
Shift and left.
We have to multiply that by, well, it's left shifting, but not in base 2. Multiply by 10. Multiple by 10, so this becomes 50, and then plus 8, so this whole thing becomes 58. When we read the third digit in, we have to multiply 58 by 10, so it becomes 580, and then plus the 6 coming in, so now we have 586. Are we still doing okay so far with this code? Let's do it in C first, and then we'll do it in assembly. In this class, unless you feel very, 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 very confident in your skill in assembly language programming, Always start with a C code before you convert it into assembly. Okay. Some people may be able to do it directly in assembly, just looking at the logic, but I think it's better to do it, code it in C first and then convert it. Let's do it. So we'll just say, this is for reading a decimal number in C. We'll do it in C first. And I cannot remember whether that's the right library, so we'll go ahead and say man to write. No, it's UNISTD. UNISTD.h. All right. So how do we code this logic in just plain C? Nothing fancy. Well, first of all, is this repetitive?
Yes.
It's repetitive, but if I tell you that we can read anything from 0 all the way up to 4 billion, the number of iterations, is it fixed? No, it's not fixed, right? I mean, I can give you a single digit, 0, and that's the end of it. Or I can give you, 4 billion something, which will be 9 digits or 10 digits. Okay, so the number of iterations I have to go through is not fixed, which means, what kind of loop do we need in this case?
While loop.
We need a while loop. Okay, very good. Either a while loop or a repeat loop here, or do while. I would say do while makes more sense. Okay, because you have to try to read it first before you can make a decision, is it time for me to get out of the loop? When do we get out of this loop here? I would type in 586 and then press the enter key. Is the enter key a part of the input or not? It is, okay? Last time we illustrated that the enter key is actually recorded as line feed or ASCII number 10, okay? So that means we keep reading and processing until we get to the line feed character. That would be the logic of the outer loop, okay? Or end of file, okay? So one or the other. So in C, we'll use CH to represent the character that I'm reading in. And I'll use it, okay, this is getting annoying, auto indent. So we'll have do while. Well, there are two conditions I have to consider here, okay? The exit point would be end of file, or we just read the line feed character. Okay. How do we read something? Since this is in C, I do not use system surface number 3. What is the equivalence of system surface number 3? We kind of went through this really quickly before the break, so I'm not surprised that nobody can remember it. I can remember because I've been teaching this class for a few years. It's the read call. Okay, so when you go out and you say man to read, this is basically the same thing as system surface number 3. EAX should have a value of 3. The file descriptor is in EBX. The location that you'll be reading into is in ECX, and then the number of bytes you want to read is in EDX. Okay, so this is a one-to-one correspondence to system surface number 3, and write is a one-to-one correspondence to system surface number 4. Okay. All right, so given this information, we go back to this program, and we'll go ahead and store the result here. This is C, so there are there are things that can be easily done in assembly, but in C it's not really so easy. So we'll go ahead and use result to store the result of read. Read requires 3 parameters. The first one is the file handle. If I want to read from standard in, what is the file handle or file descriptor? 0. Very good. And we want to specify the location to read into. I'm only reading 1 byte at a time. I'm only processing 1 byte at a time. CH is actually the address of CH. So in this case, it is the %CH because I'm using plain C. There's no pass by reference. And then the last one controls how many bytes I'm reading at the same time. I'm only trying to read 1 byte at a time. So are we doing okay so far? What is the return value of read? Let's go back to the man page. Someone is probably thinking, but Tech, aren't you supposed to be teaching the class and not relying on the man page to teach the class? What do you think?
Teaching us about the man page so we can learn.
So for things that I do not teach in the class, you can look it up yourself, right? That's the most important part, is where to find the information. Okay, so when you look at the man page of read, it basically contains the information that I told you. On success, it will return the number of bytes read is returned, and the file position is advanced by this number. It is not an error if this number is smaller than the number of bytes requested. This may happen, for example, because fewer bytes are actually available, blah, 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 blah. On error, -1 is returned and error num is set appropriately. In this case, it is left unspecified whether the file position, if any, is changed. Okay. And the most important part is here. If read returns 0, it means we are already at the end of the file. Okay, yep, go ahead.
What's an S size T? Instead of return S size T.
It's basically referring to the integer in this case, in this context. Okay, so now that we know this, we go back to the program. Can we specify the exit condition or stay in loop condition here? We'll stay in the loop as long as what? 1, we are not reading at the end of the file. So how do we specify we are not at the end of file?
Well, it's not,
When result is not
zero.
not 0, all right. And in C, there's an easy way to specify that, because I can say result, okay? Because if I just say result, it is the same as saying result is non-zero. I also want to get out of the loop if I just read a line feed character. So how do I say that it is not the end of file and what I just read is not the line feed character?
And result not equal to, what is it, 10 or 12?
10. All right, so this is the way to do it. So we basically say while result and ch does not equal to 10. Assuming that the input is already validated, it's all digits, okay? So this program is not going to check whether it is from 0 to 9. That's kind of assumed. Are we still doing okay so far with this program? Yep.
Okay, so what is result?
Result is whatever read returns, or whatever system surface number 3 returns in EAX is basically our result here. It returns the number of bytes actually read. In this case, it can only be 0 or 1. It is 0 when we are already at the end of file. It is 1 if we just read a single byte into CH. Okay. So the ordering of this is also correct because I want to check result first. If result is non-zero, then I want to go ahead and check whether I just read a line feed character. All right. Well, just the way it is, I can test the program already. Because what I can do is, I can just give it an input string, and then I can test whether it is, doing it correctly or not. But let's go ahead and do this. GCC -G -O-G read decimal.c. Oh, flip the order of the options. There we go. Okay, I don't know whether the program is working or not, right? What do I do to test this program? You can GDB your C code as well as your assembly code. So I'm going to put a breakpoint on line 9, and then put a breakpoint on line 12, which is right after the loop, and run the program. Now, in this case, I can't really run the program the way it is because it's the reading from standard in is going to interfere with the command in GDB. So how do we fix this problem? This is going to pop up. This problem is going to pop up in your homework assignment too. So I'm just going to give you a head start. Okay, the problem is standard in is being shared between the program that I'm debugging and also GDB itself. Okay. So the question now is, how do I separate the test input to the program from the commands that I'm putting into GDB? starts with an R. E, D, I, R, redirect, right? I'm sorry, just could not resist. Okay, so let's give it a try here. Okay, so we'll go ahead and GDB the same way, read decimal. But this time when okay, first of all, we still have to set up a breakpoint. So list, put a breakpoint on line 9, okay? But when we run the program, we're not just gonna run the program. You can actually specify a redirection when you're running the program in GDB, which is actually a very handy feature. So you say run redirect input for the program being debugged from a particular file. So in this case, I can pick the source file itself, read decimal.c itself. I know the first sign, the first character is a pound symbol, so that's an easy one to test. Okay, so now I'm ready to execute this instruction. Single step. Okay, I should not have single step. I should have skipped over it. What is to skip over? Well, I can always just continue, and then print ch is the pound sign. So I know it's reading the first byte of the file. Okay. The next thing I want to do is to see whether this knows when to exit. Okay. When do you think it should exit? After it reads the entire file, or after it reads the entire first line? First line. Okay, so let's go ahead and delete the first breakpoint, continue execution, and I did not put a breakpoint somewhere else, so it's okay. Run again with read decimal.c and print ch. What do you think I should expect in ch? It has just terminated the loop. Should be a line feed character. Okay. And sure enough it is. Okay. So this is a basic test to make sure that the loop itself is working, because I don't want to specify any type of base conversion stuff until I know the loop itself is reading correctly. Okay. So, but now that I know it is reading the bytes correctly on the same line, I can add some additional code to do the base conversion. Are we still doing okay so far with this program? Okay. All right, so let's continue with this program. And since I'm using get, I should say get add read decimal.c and get commit read decimal.c. Okay, now we can go ahead and make some additional changes. This also means that if I make a stupid change in this program, I will be able to go back in time and say, okay, what did I change in this program to make it not work at all? Because occasionally I can introduce a problem that makes the program worse and not better. Okay, so assuming the input is already valid, they're all digits from 0 to 9, I can now start to do the processing that I have mentioned here. First of all, I need an unsigned number to represent the value to be converted. Okay. Before the loop, num has to be initialized to 0, and then for each iteration, I have to do something. What should I do for each iteration? Just look at the stuff that we had to do here. Okay, for num itself, I have to multiply whatever num is by 10, and then add the value represented by the digit that I have just read. Is that okay? But the ordering is important. Okay, first we have to multiply num by 10, and then we add the value of the digit that we have just read. Okay, so let's go ahead and do this. So we say num equals num times 10, because we want to multiply num by 10 because we're converting from base 10 into the internal binary representation. And then we also want to add the value represented by ch, assuming it is already from 0 to 9. So that means this is just ch minus the ASCII code of 0. So just like that. Okay, is that matching the logic that we just described a little bit earlier? Multiply num by 10, and then add the value of the digit that we have just read. The value of the digit has to be the ASCII code minus 30 in hexadecimal, because we don't want to add 35 in hexadecimal to num. We just want to add 5 to the to num itself. All right. So I think this program should be working at this point. Go ahead and recompile the program, and oh, this time I need a test file that has a single number. So I'm going to use a test.input file, and we'll just give it a particular number. Okay, 596. All right, so now we can test the program. GDB read decimal. If I do not feel confident, I would put a breakpoint on line 11. So for each iteration, I would check what I'm reading in, and also whether the conversion is correct or not. If I'm confident, I can put a breakpoint on line 15. Basically just say, okay, assuming the loop is going to do the right thing, what is the actual output of this program? So that's what I would do, is to put a breakpoint on line 15, and then run the program, redirecting the input from test.in. And now we're on line 15. First of all, we want to print ch to make sure that it is the line feed character. Okay, it is, so that's good. You know what? We have a problem here. The value of num is going to be off. It's going to be a little bit bigger than what it should be. It's 10 times larger than what it should be, approximately 10 times. And sure enough, it is. Why do you think that's the case?
You should multiply by 10 on the last.
Right, it did the same thing to the line feed character. All right, minor problem. Oops, no, not this one. This means I have to guard the num, the update of num, by saying that ch has to be a digit first. Okay, so we will. There are several ways to do it. If you know that the input is already validated, they're all digits, you can just say that if ch does not equal to 10, if it is not a line feed character, then go ahead and do something to num. Otherwise, okay, I'll finish this whole thing. If result and ch does not equal to 10, because if I'm reading the end of file, ch does not have any meaning anymore because it's trying to read past the end of file. So I don't want to do any processing with ch anyway. Are we doing okay so far with the C code? Kind of? Okay. So we'll test this program one more time, and pretty sure this time it will work. GCC, GDB, put a breakpoint on line 18. Run the program, redirecting from test.in, print num, it is 586, and print ch, it is the line feed character, so the program is working now. Time to check it in, get, commit, read decimal.c. This program is now working, assuming the input is a line of digits. All right. Any questions? We may not have enough time to convert the entire program and explain at the same time today. So you can also look at this as an example where you can practice. Okay, I can start with this one, and you guys can finish it if you want to. All right. So when we work on a program like this, I will convert it into a assembly language program just by copying the file first. And then we go to the assembly version of the file, comment out everything. So we substitute the beginning of each line with a pound symbol, followed by a space, just like that. And now we can interleave our code in between. Are we still doing okay so far with this approach? We haven't really talked about local variables, so everything is going to be global. So that means we have a dot data section here, and ch is a single byte. So we can just say dot byte 0, doesn't have an initial value, so everything will be 0 in this case. Result is not strictly required. Okay, it is not strictly required, but we'll put it in here so that we can implement exactly the same code as in the C code. This is going to be a .int 0 because it's 32-bit, and then we also have nums. I need to redo. I just hit undo, but I cannot remember how to redo in VI. Vim, redo. Control R will redo. Thank you. Oh, great. Fine. Hmm? It's not that big of a deal.
Maybe let's change this buff.
No, I have not committed yet. In fact, this file has not been added to the repository yet. It's no biggie. Okay, so that finishes all the declaration of the variables. Now we can switch back to .text, .global underscore start, underscore start, because we don't have main. And we'll finish up the entire program here. Move 1 into EAX, 0 into EBX, and request the exit. All right, so I'll try to finish as much as I can in the next 2 minutes, and then you guys can try to finish the rest as a brain teaser. Okay, num get 0, that's pretty easy. Move 0 into num, because it's just a global variable. This is a loop. With any type of loop, we need a loop begin label, because eventually we want to go back to the beginning of the loop. Okay, so now we want to get to the end of this label, okay, which basically says we want to go back to the beginning if result is non-zero and ch is not 10. Okay, so that's what we want to do. Which also means we can say, well, but when are we actually going to get out of this loop here? Okay, so we will have a loop exit label here, because it's easy to figure out when we're going to get out of the loop. First thing is to compare result to 0. If result is in fact 0, we are looping, we're getting out of this loop. Is that making any sense? Okay. Assuming that result is non-zero, now it's time to compare ch. So this one you have to be very careful, because if I do something like this, what do you think is going to happen? J and Z to loop begin, because I want it to be non-zero. Okay, what is the problem here? There's a very serious problem, but it's really hard to spot.
Oh, yeah.
Yep.
You're long.
Yep, exactly. ch only has 1 byte allocated to it. So if I do a compare long, what do you think will happen? It will compare the 1 byte that really is ch and 3 additional bytes. Okay. And where do you think it got those 3 additional bytes from? Well, if I go back to the beginning of the program, it's getting it from result. So it's going to grab ch, the dot byte, and then the first 3 bytes of the next dot end for comparison. Now in this case, the program is going to do something weird, because it will never match the line feed character. Because result is either a 0 or 1, right? If result is a 1, then that 1 will become a part of the comparison. And then I'm only comparing that to 10. So that's why this comparison will never work. It will never match the line feed character the way it is specified. Okay. So to fix that problem, I know we are going a little bit over time here. So to fix that problem, you have to change this compare long to just compare byte. Specifying the right width of operation is very important in assembly. It's something that you don't have to do in C and C++ because the type of your variables automatically determine how things should be done. But in assembly language programming, there's no such luxury. You have to control the actual width of the operations. So we'll just leave this one as is right here. For those of you who want to give it a try to finish the program, go ahead, but don't spend too much time, because there is one operation that is a little bit tricky. I'll point it out right now, just so that you know what to watch out for. This one here. This one is a lot, well, I wouldn't say a lot, but it's more complicated than it seems, even if you know how to do multiplication. Okay? So we'll just leave it the way it is, and then I'll finish the program on Thursday, but go ahead and give it a try if you have time.
Just to make sure, we're not accepting either input in our homework, right?
Sorry?
We're not getting input in our homework, right?
With your existing homework,
With the homework on Thursday.
you're not accepting the input.
That's what I thought.
I'm
You're just
using-
going to inject stuff in.
Using GDB.
Okay.
Yep.
I'm just making sure.
So as long as you follow the labels, label L1, label L2, and then the names of the variables, you should be okay.
So for our loop, we just use. We can use okay.
Correct.
If I email you C++ questions, will you answer?
Only if I know what how to answer.
Okay.
So I won't spend too much time to research, because
Yeah,
I
yeah.
don't know offhand.
Although I wouldn't be
Yeah, okay.
surprised that it exists.